Good morning, students. Today, this is the sixth class of time series analysis, and as in my last class, I have discussed about the measurement of seasonal variations. I have discussed the various techniques while we use while measuring the seasonal variations. Today, I will start with doing a sum where it has been dictated with seasonal indices. Okay. If you go through the sum which I have been given in your PDF, if you see that it is said that quarterly sales rupees in thousands of a company is given below. Quarter has been given and year has been given. There are 4 quarters in a year, and the year has been from 1996, 1997 and 1998, which has been given in the sum. Okay, so there are 4 quarters. Each quarter sales figure has been given. You have to calculate the seasonal indices using multiplicative model. Okay, you have to calculate the seasonal indices using multiplicative model. So when you are doing that, how you can do that? Okay, this is sum number 1, that is example number 1. Okay, calculation for seasonal indices, for seasonal indices. Okay, so quarter has been given, and years has been given, 1996, 1997 and 1998, right? Quarters and years has been given in the sum, and total it has been provided, right? Total you have to add that, and you have to calculate the averages also. You have to calculate the averages also, right? Okay. Sorry. So there are 4 quarters, 1, 2, 3 and 4. 1996 sales figure has been given, 7.2, 5.0, 7.2, 5.0, 7.8 and 9.2. Here 1997's quarter sales has been given 7.4, 6.8, 7.4, 9.0, right? And 1998 it's 8.4, 6.0, 6.2 and finally 7.6. Total, you just added up these three. What is coming? It's 23. If you added 5 plus 6, it's 11 plus 6, 17.8, right? Is 7, 7, 14, 14 plus 6, 20, 20.8 plus 4, 21.2, 21.4 it is. And 9, 9, 18 plus 7, 25, 25.8, right? You can make the averages. How? Total divided by 3 means 23 divided by 3 is 7.67. 17.8 divided by 3 is 5.93. 21.4 divided by 3 is 7.13. And 25.8 divided by 3 it is 8.6, means 8.60. If you add it, that is the grand total, grand average. Total grand average. Okay, total grand average. If you add this, it is coming 29.33. Acha, while you have to do the multiplicative model, first of all you have to find the averages of average, means grand average. Average of total grand average is equal to 29.33, and how many quarter? It is 4 divided by 4, it is coming 7.33. So what will be the seasonal index for quarter 1? You have to do like that. Seasonal index for quarter 1 is equal to average of that quarter, means 7.67, divided by average of the grand average, which is 7.33, into 100. Okay, average of the quarter divided by average of the total grand average into 100. In this way you can get the seasonal index of quarter 1, which is 104.6. Next, seasonal index for quarter 2, average of the quarter 5.93 divided by 7.33 into 100. 7.33 is average of the total grand average, it is 80.9. Seasonal index for quarter 3, it will be 7.13 divided by 7.33 into 100, it is coming 97.2, right? And seasonal index for quarter 4, it is 8.60 divided by 7.33 into 100, it is coming 117.3. So you have to keep in mind, since the total of seasonal index for 4 quarter is 400, obviously, as the total will be 400. How? 1 quarter is equal to 100, so 4 quarter is 400. So in this way, no adjustments in this case is required in this case. So this is the way you have to find out in case of multiplicative model. If it is an additive model, I have to show you the way how you have to calculate in the additive model in my next sum. Okay, so I hope it is not so complicated, it is an easier one to understand. It is an easier one to understand, I hope. It's not such so difficult to understand, right? So coming to my next sum, which is compute the average seasonal variation by method of average for the following data using addition model or additive model. Again, 4 quarter has been given, 4 years has been given, 2000 to 2003, and 4 quarters, and you need to make the averages of that. Okay, how you can do that? This is the sum. Okay, so if you done with this, we can easily go through the sum, right? Okay, I'm rubbing this off. I'm coming to my next sum, which is you need to calculate averages of the seasonal variations, right? Okay, so calculation of, this is example number 2, right? Example number 2, calculation of average seasonal variation. Average seasonal variations, right? Year or quarter has been mentioned. Quarter has been mentioned. It is 2000, 2001, 2002 and 2003. Quarter has been given 1, 2, 3 and 4. Okay. So quarter, in place of quarter it is given 30, 31, 30, 33, 34, 27, 18, 24, 29, 30, 28 and 34, 31, 29, 25 and 30. If you add this, that will be your total. 30, 34 is 64 plus 29 is basically 93 plus 31 is basically 124. 30, 27 is basically 58 plus 30 is 88 plus 29 117. Okay. And next one is 30 plus 18, 48, 48 plus 28 is 76 plus 25 is 101, 101, and 33 plus 24 is basically 57 plus 30 is basically 87 plus 34 is basically 121. And if you make that is the grand total. If you make that will be the grand total. 124 plus 117 plus 101 plus 121 is 463, right? Okay, you don't need to calculate this also, don't need to. And what will be the average? You know the average. 124 divided by 4, it is coming 31. 117 divided by 4, it is 29.75. 101 divided by 4, it is 25.25. And 121 divided by 4 is 30.25. And finally 463 divided by 4, it's 115.75. Okay. Now you have to keep in mind, you need to calculate this average of the 4 quarters, and on that basis you can compute is there any seasonal variations or not. What you have to do, you have to calculate the total averages average by 4 quarters, and on the basis of that you need to find out whether there is any average seasonal variations or not. Okay. Grand, therefore, averages of average for 4 quarters, 115.75 divided by 4, it is coming 28.94. Now you have to compare whether there is any seasonal variations or not. You have to compare whether you will find any seasonal variations or not. See, obviously if you deduct this with this one with this one, you will have a variation. Therefore, average seasonal variation as it is an additive method, the first one will be 31.0 minus 28.94. It is 2.06. For quarter 2, it is 29.75 minus 28.94. It is 0.31. For quarter 3, it will be 25.25 minus 28.94. It will be minus of 3.69. For quarter 4, it will be 30.25 minus 28.94. It will be 1. Let's calculate. 30.25 minus 28.94, it is 1.31, right? It is 1.31. And final column, the total column, it will be nil, obviously. 28.94 minus 28.94, it will be 0, right? It will be 0. So there has been a seasonal variation. An average seasonal variation you can compute with the averages of the average, and for that you need to calculate first the average of 4 quarters, and then you can proceed of doing what it is required. So this is what for today's class. I hope you all understand this thing. Thank you for patient hearing. Have a nice day ahead.